Okay. So, in simple terms, how do you explain composite AI to a business leader who's heard of Gen AI but hasn't really heard of, the other ones, unsupervised, predictive, or causal?
Yeah, I think generative AI has been actually widely known now because people look at ChatGPT, and so ChatGPT is invented to essentially predicting text, right, for natural language. So this is one type of machine learning technology that works well for like human language. But there's a lot of data. So data has different format. There's numerical time series data. There's categorical string data. There's basically unstructured or semi-structured data. There's image data, audio data. Particularly in InsightFinder, we look at machine data, right? So the data produced by computers, not by human. So fundamentally, there's a big difference between these two type of data. So for human language, there's a lot of basically predictability, right? Because human language, although we have different ways to express ourselves, but the fundamental rules, grammar, is actually quite limited. So in contrast, so if you look at the machine data, right, the data produced by computers, by complex IT infrastructures, so the data is a lot more noisy. And you look at the data, there's a lot of variety, there are a lot of fluctuation, there's a lot of different kinds of rules and patterns, right? So if you look at the rules and patterns, machine data essentially has unlimited amount of data. That's why the AI technology invented for human language analysis is not typically suitable for machine data analysis. So that's why you will see basically in the past, right? So we see clustering technology used by IT monitoring tools to analyze machine data because the clustering algorithm can identify more patterns. However, those basic traditional machine learning technologies has a set of like inherent challenges with regarding to the data complexity and dimensionality. So particularly if you look at basically one big category, right? So when you first look at the problems, you want to see, okay, is there any anomalies or problems in my infrastructure? So this is traditionally characterized by anomaly detection, that kind of problems. And so we want to actually detect anomalies without having human to label the data, right? So for like I mentioned, like natural language, you can have human to label the data and to train your model. But for machine data, it's almost impossible to do that, right? So that's why we need unsupervised technology to tackle that. Clustering algorithm is one type of AI algorithms, but it's basically suffers from curse of dimensionality for complex machine data. So that's why, so at InsightFinder, we invented a high dimensional, highly scalable, multivariant anomaly detection algorithms that's use unsupervised AI to detect anomalies accurately. But basically, in the IT systems, and it's not sufficient that you just detect anomalies, right? So you also need to know why these anomalies happen. So that's basically related to a very big challenge in IT system called root cause analysis. Now, root cause analysis means that you need to figure out, okay, among many, many different problems, anomalies, what are the relationships among them? So in AI technology, this is basically called causal inference, right? So you want to figure out the relationships among different data points, among different patterns. Those algorithms typically require you to be able to perform like many pairing computations among large number of different kinds of data, right? And this is particularly challenging if you want to perform the causal inference over dynamic real-time data, right? That's also not basically traditional NLP technology like GenAI can handle because again, like I said, human language, we although we have different ways to express ourselves, the dynamics in those data are actually quite limited compared to basically machine data. So that's why you need a different technology to perform this causal inference, right? This is what we call causal AI. Causal AI is not trying to figure out patterns or perform predictions, but rather to figure out the relationships among different data. That's the second category of the AI technology we believe that's necessary for tackling the IT system observability and the management problem. Then the third category is prediction. Essentially, GenAI is also a prediction technology, right? It's predicting the tokens, predicting the text in the human language. So like I said, right, so like our human language is very kind of predictable, right? Because we have much less basically rules and much less diversity in our language. But in contrast, if you look at machine data, particular real-time time series data, there's a lot of different, trending. There are a lot of different patterns, a lot of situations. So the prediction is quite different, right? So the technology works for human language, not necessarily working for machine data. So that's what we call predictive AI. Essentially, no shoes fits all, right? And so you for different type of data, you need different technology. And even for prediction technology, there's basically cyclic periodic patterns. There's basically different fluctuation up and down, different trending patterns. So it depends on the patterns of the signals. You probably need a different prediction technology to perform accurate predictions, right? So like, for example, for seasonal time series, we can use Fourier transform to try to figure out the repeating patterns. And then based on the repeating patterns, then we can predict, okay, is this actually going up or down, right? So very commonly, you can see in production environments, you have these cyclic patterns across different days during the week, right? So for example, your Monday traffic typically is high, and then your Sunday evening traffic is low. So you can actually capture those different patterns and perform predictions or anomaly detection. So those are basically four different categories. We try to identify different kinds of key problems, right? Just to recap, right? So we talk about anomaly detection using unsupervised AI. We talk about the causal inference using causal AI, and then we talk about prediction using predictive AI. Now, finally, we do believe basic general AI is a very important piece to connect basically very noisy, very abstract machine data with human, right? So because we are not good at understanding basically numerical data, right? So if you actually put hundreds of line charts in front of human, it's probably very hard for him to figure out what's going on, right? But if I summarize it in natural language, I say, okay, I detect a CPU spikes on one of my database nodes. So I tell you, okay, my problem summary here is that you have a service actually slow down because you have basically a CPU spikes on one of your database nodes, right? If I explain that in human language like this, and so it's very easy for basic operators SREs to understand quickly what's going on in their system so they can actually take actions, right? So that's why we believe, composite AI is necessary because you have different types of data in your environments and you need a different technology to handle that.
Piggybacking off that and going a little bit deeper, why is it risky for an enterprise to really rely on generative AI alone to build a trustworthy AI system?
Yeah, so because generative AI is typically represented by those foundational models, right? So people familiar with ChatGPT, with Cloud from Anthropic. So those foundational AI models are trained by many data set which is public available, right? Either on internet, and it's trained based on common knowledge, right? Common cases, common knowledge, but it's not necessarily actually fit your environment, right? So particularly if you look at enterprise use cases, each enterprise has their unique thing, right? So if you look at, I'm talking about airline companies, or I talk to e-commerce companies, they have different types of, workflows. They have different types of data. They have different types of problems, right? So if you actually take the kind of like a common knowledge and to fit different environments inevitably, right? So for like generic problems, like if you ask generic questions, okay, what is 1 + 1 = 2? And so these kind of things, that of course it's simple to answer, but if you ask specific things, right? So, what's the best peak kind of season for this airline company, or what's the peak season for this e-commerce company, the answer may be quite different, right? And the answer will based on the specific company's data as well. So it's very important to actually fine tune those models and based on your specific data. Now, foundational models is not doing that because, GenAI basically is based on this applicable generative AI technology that works for everybody, right? That's the design goals of those models. So inevitably, those models are not actually customized and tailored toward your specific environments, right? So that's a cause a lot of like, potential problems for hallucinations, and it's also cause problems for actually giving the wrong answers, right? So for example, like a very common example, I would say, like if you are basically a company selling like a Windows operating system machines, and so if you want to have system to like answer customer calls saying, oh, my machine crashed and here's a error code, and what does it mean? And so if you ask the ChatGPT, it will give you answer, but it's totally wrong answer. And if you don't know, if you're not expert in that domain, you probably will trust those answers, right? That's a problem, right? So foundational models can be very confidently wrong, right?
Mm.
They don't tell you I don't know. They will always give you answer because that's sort of how probabilistic machine learning model design is, always give you answer rather than tell you I don't know. So that's very dangerous, right? Because if you actually give this tool to your people, and then they don't necessarily be the expert in each domain, and they will trust the answers from the foundational models, and they will actually make wrong decisions based on completely wrong answer, right? And sometimes it could be actually very mission critical decisions for your company, right? So that's why we believe it's very dangerous to just deploy those generic foundational models to serve your purpose. Yeah.
To piggyback on that, what I would say is when it comes to building reliable services in production, there is a particular model for detecting what are the outliers in this performance curve and what are the causal attributes behind that. And there's a science to it that is very, very specific in looking at baseline performance versus, anomalies that you find interesting for a particular reason. And that is very exacting. Whereas I believe what Helen is saying is from a generative AI perspective, LLMs are looking at probabilistically, right? Based on, the training data that I have on how language works, what is likely the right answer versus a set of AI that is tuned specifically to look at machine data to figure out where those outliers are with minimal instructions and be entirely accurate, right? And to Helen's point, if you're not a domain expert, it's very likely that you will be given an incorrect answer and take action on that. And that's where the danger is, right? Do we know where we're going wrong? Do we have that domain expertise? We may or we may not, depending on the system and who's in front of it, right? And that amount of guesswork is, I think, why a lot of people have a hard time trusting generative AI in general or AI applications overall, right? And so a composite AI approach is taking the right tool for the right use case to get as much accuracy as possible for the type of problem that's trying to be solved, right? Rather than taking a general approach, let's use the right tool for the right job that we're trying to accomplish.
Yeah, it's basically hierarchical approach, right? So like essentially you want to extracting insights out of many data and provide answer to a specific question. So if you actually just rely on general AI to do this kind of like information extraction, and sometimes the information extraction is based on just some statistical rules, right? Rather than built-in causal relationships. That's why we believe you need to have the right tool to do anomaly detection, to do causal inference first, to kind of extracting the information that are relevant to the specific question. And then you can use general AI to actually transform that kind of numerical information into human language that's easier to
When
understand.
we look at the composite or the 4 different types of AI that make up composite AI, when you guys look at this, what is the one that customers tend to undervalue the most? Why do they undervalue this particular type of AI?
So that's a great question. I think a lot of customers, first of all, I think AI appears as a black box to a lot of people. So most of the time, if they are just users of AI, so they don't actually know what's actually behind the scene for those AI. It's just like a black box to users. And so a lot of people think, okay, I just get the input, I get an output magically, right? So it's more like a crystal ball to people. So I think so the general AI is actually pretty powerful because it's kind of like describe the insights from a machine, from an AI model to human using human language, right? So that's sort of that's why ChatGPT gains so much traction. Although AI technology has been under development for the past, I would say, 60 years, and so a lot of models, right? Even like GenAI, like ChatGPT technology is now new, right? So the technology they use already exists, but they apply to natural language and they develop this powerful, make people understand, oh, this can do really great things for human language, right? Now, a similar thing here is that I think a very big space is machine data, right? So machine data means those data produced by our computers, networks, storage devices. And so there's a lot more data than human language. And so it's very difficult to process them, right? So that's why we still have so many outages. We still have downtime, right, from the most leading technology advanced company. Among those, so composite AI, I think it's basically a generic umbrella term for any AI technology, right? So we are not saying like the 4 AI technology we talk about here, the only AI technology for composite AI, right? So we are trying to actually advertising here is a kind of like a more holistic or like principled approach to tackle complex real world problems, and depending on the problems you are tackling with, and the different models could work for different use cases better or not. So I think most of in the AI observability or IT observability space, I think most of the challenges people look at is that, okay, I have a lot of alerts, and how do I figure out which alert I should actually focus on, right? So traditionally this is called alert reduction, or kind of like trying to reduce the time to analyze those alerts. But quickly people realize, okay, if you have a lot of alerts and all those alerts are false alarms, and you reduce like 1,000 false alarms to 10 false alarms, it still doesn't actually help you to figure out what's going on, right? So those are not the essential challenge when you try to prevent those problems. So a lot of things that are kind of overlooked is that in order to actually figure out the root causes or generate the right fix, the first step is to have high quality alerts, right? So that's where the unsupervised AI is essential to discover those anomalies. And once you have that, actually the causal AI is coming from like very naturally, right? So you can do causal inference pretty good if you have high quality alerts. Now,
Let me
the other, yeah.
go ahead.
Now the other thing is that basically I would say like the value behind basically detect those problems early and then figure out the root causes is really to prevent the problem, right? So at the end of the day, if you have alert reduction, but you still have incidents, right? That's still basically reactive, because when you have a big outage happens, you got a lot of alerts, then you start to analyze it. That's too late, right? So we want to bring people, ahead of those incidents, outages. And so in order to do that, you need to have these high quality alerts. You need to have basically the right kind of causal chains for you to understand what's the impact of those alerts, right? So that's basically, I think, some of the value people look at the end result, but not actually going back to the source of the problem. I think that's the key we trying to tackle using composite AI.
So let's go ahead, please.
Let me give you another perspective on this, putting my business leader, like technology leader hat on in terms of what's undervalued the most, predictive. And I'll tell you why. Because prior to the current era that we're in, we had a lot of quote unquote AI ops tools that were in practice. And a majority of those were just algorithms that did grouping of alerts, like Helen was mentioning, right? And they were really, really bad at finding relevant outliers that were actually responsible, like the cause of some outages. And so if that just wasn't working, there's no way that you could make an accurate prediction. And I think a lot of technology leaders are just used to the fact that it's garbage, right? Garbage data in, garbage data out. And so if I don't have a great way to do causal analysis, predictive is going to be completely undervalued. And I think a lot of folks just don't see the value in unsupervised AI, right? And so to Helen's point, I think the way that it comes together is the unsupervised AI, right? Just you can let loose on a data set. It will automatically learn how to tag it, where the baselines are, where the outliers are. What are those interesting points that typically humans need to comb through tons and tons of data to find and use lots of different visualizations and charts to get to the bottom of, right? We can just give that to AI. It finds those. And then with causal analysis on top, we can find, well, what are the actual underlying attributes that are responsible for those peaks and outliers that we care about? And if that's solid and that is accurate, well, then guess what? You can actually start to make predictive predictions that are actually accurate about what may be about to happen in your environment, right? But I think as business leaders, we're used to those underlying foundations that make prediction possible just being garbage. So the predictions are garbage. But if you get it right, there's so much value in predictive AI that is untapped. And just whenever we talk to customers, generally shrugged off or not believed because we have been just conditioned to think that those predictions are just not accurate or not going to happen. But when we talk to InsightFinder customers, we generally see they find a ton of value there. And I think that's actually pretty exceptional.
What is the value from a business standpoint of being able to deploy on premise or in an air gapped environment? Is this just beyond compliance or beyond just compliance?
It's definitely beyond just compliance. And I think for a number of organizations, data sharing, understanding what's being done with my data, where is it being retained, who am I giving access to see all of either my proprietary data or just customer data, or even just sensitive data that may not, have a lot of commercial risk, but that just raises some eyebrows of who are we letting into our infrastructure. Being able to run in an air-gapped environment, meaning, right, something that is not connected to the internet, running wholly on your infrastructure means that there's a certain amount of sovereignty that you have over your own data, right? And regardless of the rules that you put around how your data is shared or whether it's, it goes back into the public training pool, I'll give you a random example of what happened recently. I use ChatGPT a lot, and I was doing a creative writing project, asking just, for a couple of examples of something that I would write. I was actually doing like Civil War era letters for something completely not business related. And about 6 months ago, I asked ChatGPT for advice on buying a new vehicle. And in the middle of this Civil War era writing exercise, because I was at the DMV and I used that as a funny situation, it inserted data about the vehicle that I'd been asking about. And I realized, oh my God, this knows way too many things about me, right? And it was able to connect dots in very unexpected ways. And I think, that's a very trivial, like very, banal example of things that can happen. But I think at an enterprise level, especially if you are subject to regulations like HIPAA or SOX or any number of regulatory concerns that do touch on compliance, that becomes very, very critical. But even in competitive situations where you are giving LLMs proprietary data in order to help them make decisions, who really has access to that? What's really happening? I think data sharing is a paramount concern to most business leaders. And when it comes to using quality check products to understand what your services are doing, how they're interacting, the fewer points of exposure you have, the better. And so the ability to run in an air-gapped environment is absolutely of key concern. And I think it's something that we don't see in the space enough.